So today I'm going to be talking about discriminated unions, since we've had several talks recently about frameworks, but a lot of the time we keep getting questions coming up about basic language stuff, which is on the screen. So I wanted to kind of cover this because I think discriminated unions are probably one of the first bits of the kind of basic stuff, which really kind of sets it apart and makes you go, all right, yeah, I can see why maybe this would be an alternative to OO. And they help in sorting a bunch of problems. They help you with, well, not needing to throw null around. They help cut down on needing things like guard clauses, and they streamline your validation. And like I said, they're a good valid alternative to OO because they also kind of give you polymorphism or something close to it. So I'm just going to throw stuff up into a script file here just to sort of like demonstrate as I'm going along what I'm talking about. Can everyone see that okay? Is that a good size? Excellent. Okay. Let's go. That is not at all what I wanted to do. I'm trying to be too clever. That's quite good. Cool. So, first of all, let's just have a bit of a recap on the basic types you get in MancFUG. So, obviously, you get primitives. Primitives, you get strings, bools, ints, everything you'd expect, not very interesting. Let is used instead of var if you come from other languages. Type is inferred, as you can see there's sort of code length going on there. Primitives. You also get tuples, which allow you to have from multiple. So this is two strings going together to make a tuple. You get records. So notice this time, for the first time, I'm actually declaring that this is a new type. And the record is really just, that's kind of like a tuple, but with labels for the fields. So. And then so it's like a tuple, but you've got labeled fields there. Once again, type is inferred. It's inferred that that's the type of full name. And records kind of get you reasonably far. They're like data structures, as you'd expect in C, C++, or C#. So they get you reasonably far. You might go, okay, so we've got an account. An account has an ID, which is an integer, and there might be contact details, so they might have an email, so it's a string. They might have a mobile number, which is also a type of string. So we've got an account, and all's well in the world. But then someone from the business comes and says, oh no, they don't need an email and a mobile. They just need contact details, and contact details could be, well, it could be an email or it could be a mobile. And you go, okay, so you could go count 2 equals, well, ID int and contact details of type object. But that's not really going to cover. So limitations of records there. It's straight up data structure. You've got to have all those fields. But in the real world, we do have things like contact details, which could be one thing or another, and this is what discriminated unions cover. In other languages, I think in Haskell, they're called tagged unions. But discriminated unions are used to hold a value that can take on several different types, but can only hold one actual value. They could be several different things, but they can only one of them at a time. And they can hold a value, so it's kind of holds a value and it's tagged with what its type is. So let's have an example. Let's say I have type contact details. Let's talk about type contact details. Okay, so contact detail, as we said, it could be an email, or it could be a mobile. Although you can write it all in one line, it is more common to actually split it out. So, what does that actually look like? Let's have, okay, let's, my email, probably go on YouTube, I don't think I'll put my actual email address on. So, now I've used the discriminated union. So, I've got contact details, and that could either be an email or a mobile. And what we've got here is actually a constructor, or it describes the constructor. So, I make an email, and I need a string to make one, like I'm doing here. Now notice also that it actually sort of shows that the type of my email here is contact details. Is everyone familiar with abstract classes in, say, C#, Java? It's kind of a close approximation on this. So discriminated union, like contact details here. So contact details is sort of the abstract class. It's a thing, you can pass it around, things understand it, but you cannot have a contact details thing. There is no such thing as a concrete implementation of contact details. You need the sort of child class of it. In this case, we have email and mobile. Of course, this doesn't just apply. You can use other things. We don't just need to use primitives. I could easily throw in a record here and go, okay, so we could also have a landline. Well, there's a phone number and an extension. And I can add this in as well and just go, okay, so one landline of landline. I'm overloading the terms landline here, but F# will probably be smart enough to work out which one I mean in which situation. So, like I said, in Haskell these are called tagged unions. So what we're saying is that contact details includes a set of all things which are strings, which can be tagged as emails, strings that can be tagged as mobile numbers, and landline record types which are tagged as records. And then once we've got that, we can rewrite our account in a more useful way. So if I was to say, now I can actually say, yes, I have an ID, which is an integer, and I have a contact details, which is of type contact details. So now, whenever I make an account, all I need is one set of contact details. In fact, the way I put it in here, it is just one contact details. It's an email, a mobile, or a landline. They have one and one only. Well, that's kind of all well and good. So if you actually wanted to contact someone, you go contact X equals but what if X is contact details? So if I was to just go versus, I'll actually make this into a contact details. Just specify the type here. I can't just say print contacting X. It's not going to be happy with that. It's like, there you go, okay. If this was an OO, if this was an abstract class, then we would have different ways. Each of them would implement a different way of doing the contact. We want to contact, okay. The email class knows how to contact its account. The landline knows that it needs to sort out an agent to call. Mobile knows it needs to send a text. Functional programming languages, obviously, discriminated union doesn't have behavior itself. None of the types have their own behavior. It's hybrid, you can sort of fudge things a little, but I don't know what I just said. But in functional, what we'd actually do is sort it out with some pattern matching. Is anyone familiar with pattern matching? So I've got contact and I might say, okay, so match X with, well, it's an email button. Print function, emailing, email. So the sense being, tell you. Mobile. Similarly, it would be Instagram, texting, be less helpful. This is interesting. What we're doing here, we're doing some pattern matching. So I've got X, which is of type contact details. In fact, now that I'm doing pattern matching, you can infer that, so I don't need to specify that. And it's actually matching, well, as I said before, when we were putting this together, these here are constructors. They describe, it's a string value and it's tagged as email, it's a string, it's tagged as mobile, it's a landline and it's tagged as landline. So we used it to construct, like we're doing here. I'm constructing it, I'm saying email, here's the string. However, these are also used for deconstructing. So what I'm saying here is, okay, I've got a contact details, X. If you can match it with something tagged as an email, which is a string, then I'll bind the string to that value email, then you can see it's a string. And now I've kind of unwrapped the string out of the email, and I'm printing it there. I'm unwrapping the mobile phone number here, I'm texting it. I've also got something interesting here. If I go over the X here, it's actually giving me a bit of a warning here, because it's saying, oh, but it could also be a landline, and you can put in no behavior for that. Landline, of course, was a record, which I can also deconstruct. So the description I had before for records is also not just a constructor, it's a deconstructor. So I can say, oh, there's a field called number. And so there's a field called number. So assign that, which will be string, assign it to num. And there's one called X, and I'll assign that to X as well. And now, use some then agent calling you with me so far? Any questions?
Is that, sorry, Andy, is that not the wrong way around? Because you've assigned num to, do you know what I mean? You've kind of decomposed, do you have to, because you've used number and X in your landline record, but you want to use num, do you know what I mean?
So, if I change that, then it complains. So, the field is tagged as number.
Is all around depth and num X.
Let's change that to.
No, yeah, that's right.
X and Y. Yeah, looking at it, I can see where you're coming from. It does look like it's. I know, because it's if you think about it, it's like the we're using it as a constructor. If I have a look at the given name here, I'm saying given name equals Andy. I'm doing the same here. Number is the label. It's the same way around it would be if you were assigning it in a constructor. It's the same, isn't it? So if you think about it, pattern matching is a bit like when you're doing algebra at school, and you've got a formula on one side and a formula on the other. You've got x plus 3 divided by y equals something on the other side, and then you can start balancing out, and until it finds something that matches, and you end up with like x equals 4. This is kind of similar. We've got, this is what the property is in the record, and now just try and find something which matches that, something which works with that, and we'll assign it to the label num in this case.
So could you swap those around then, num equals number?
No, if I try doing that,
That's kind of what I was thinking.
it will complain that it doesn't know
What num is?
Yeah, the record type landline does not contain a label num.
It feels a bit backwards, doesn't it?
Yeah, it's. I think it's this way so that it can be the same. Constructing and deconstructing is the same.
Yeah. Can you just do it positionally as well? Can you just have num and X, or do you have to assign the labels?
You could with a tuple, but with a record you need to have the labels. Although interestingly, also what you can do, you don't need to use all the bits from it because it's.
Yeah.
Since it knows what the record type, you don't have to deconstruct everything.
Yeah.
Is there a limit on how many parameters you can deconstruct? So I think in Scala there's like a limit of 30 something.
I don't know off the top of my head. But I would say if you're deconstructing 30 in a go,
Probably too many.
it's probably not quite right. So no, I don't know off the top of my head. That's the answer to that.
Could you also use that to match for specific numbers? So say you only wanted mobile numbers, do a starts with 0 setting.
I think you can put conditionals on it. And I can't think off the top of my head what that looks like, but I think you're right. Is it like where or something?
Yeah,
When,
yeah.
But yeah, I can't remember off the top of my head, so I'm not going to get too experimental right now. So yes, you can actually do multiple matches against the same tag, but actually put parameters on them. And also, if you really honestly don't want to match, you can just do kind of wildcard, underscore, anything less. But it's kind of considered bad practice to do that because you might accidentally be swallowing you want. Anyway, so this is interesting because this is kind of the exact opposite of OO. In OO, you're encapsulating state and behavior in an object. Behaviors in an object. In F# specifically, the behavior is completely separate and standalone. And this means that if I want to do something new, I decide new behavior, I want to add new behavior, can't think of any off the top of my head. do something, I've got some behavior, I want to do something else with an account, with contact details, then to add new behavior is as simple as just sticking another function in, pattern matching it, and doing more of the same. It's just the same. So new behavior is just added by adding a new function. So that might be, yeah, in this case we've got actually contacting some contact details. There might be, I can't think of very good examples with contact details. Fail. But this is interesting because OO is often sold to us as the best way of doing things, and it's the best for behavior because it encapsulates state of behavior. But it has an interesting side effect, so that it makes, because behavior is encapsulated, it makes it very easy in OO to add new types, because all the behavior is on there. You've got the interface, you've got the abstract class, it's all there. You just make one new object, implement behavior at the interface, fill in all of the abstract methods, and bang, you've got a brand new type. However, it's actually quite hard to add new behavior in OO, because you go, all right, I have the abstract class, I will add an abstract method on it, or I've got an interface, I'll add an extra method on it. Boom, instantly the code breaks for everybody. You go, okay, well, I know about email, mobile, and landline because they're part of my core project. So I now go and add behavior onto each one of those, so it'll compile. Unfortunately, of course, someone else has also got a copy of my code, and I don't know about that, and they update, and they've made another contact details. They have, they've added addresses, and they update their library, and boom, it's gone bad. It's blown up again for them because now they're missing this behavior. It's kind of interesting. OO is sold as this big thing, behavior driven. It's difficult to add behavior in an OO language. In F#, adding new behavior is as simple as just adding another function, filling in the pattern matching for all the available types, and you're done. Similarly, if new types are added, I get a bit of a warning that I haven't sorted out behavior referral. And I think someone did say, I did read somewhere that someone had done big analysis of projects and found that it is far more common to add new behavior into a project than new types. Once a project's up and running, new types don't actually happen very often, but new behavior does. Which I found interesting. I don't know what people's experience with that has been. Oh yeah, let's talk about something interesting and not obvious applications. Let's say we've got a account record here that has an ID, but it's also backed by some sort of database, and we've normalized things a bit, and we've got an address ID which is also an integer. So this account has two IDs in it, and we'll go say do something to account X, which takes that account ID and will do something to the account. Does something to the account. So what could possibly go wrong with this? I've got an account, I get the ID out of it, so I pass it into some method, function, or whatever that does something with an account. Well, the problem, or one of the problems, is that the ID is just an integer, and there's nothing to stop me taking the address ID by accident and doing something to that. Don't know what the side effect of that will be. Probably not what was intended. And possibly difficult to actually trace back. It might not be immediately apparent that something's gone wrong. So this is obviously in C# or in Java or OO languages we call this primitive session. The problem is that, of course, it's not really, although we're using an integer to represent that ID, it's not an integer what you want to pass around, it's an ID. And there's a very simple way to fix it, which is we can just go, okay, let's make a discriminated union. I don't even know how I got that one. No. I can actually mix it pretty easily by actually just saying, I'll make a discriminated union here with a single case. I've got a discriminated union of account ID, and it has one case, which is there's an integer which is tagged as an account ID. And this is it. I've now wrapped up that integer type there behind the account ID. And I can now make this function type safe by saying, well, it's the exact same thing now, except this function here, which needed account IDs to work, took an integer. If someone accidentally passed me any other integer from the program they got from anywhere else, it would blow up, it would do something unexpected. However, I can combine discriminated unions here with a single case discriminated union, mixed in with some deconstruction on my method signature, function signature. And now I have the same function that does the same thing, it's still working on an integer internally. However, it will only accept an integer that has been tagged as an account ID. And then I unwrap it in the method, I keep saying method, sorry, we're in functional oriented. I unwrap it in the function signature and use that instead. So obviously it's pretty easy to do this in OO as well. It just means every time you want to do it, it's quite a bit of boilerplate, so we'll skip over it as a bit of work. But in F# and other languages like Haskell as well, it is really easy to do that. And people see the use of that. So now it means that instead of passing around primitives everywhere, you can no one can accidentally pass you the wrong integer or the wrong string. So that's kind of a whirlwind tour of discriminated unions. I think I've covered everything on the basics of the syntax and the semantics, other than the when clause, which I really do need to look into. I should have thought of that for this.
And function as well. Function, yeah, I was going to say.
Yes, all right. I should have researched harder, but I know I spent half an hour playing with the ASCII art generators. So. Yeah, but I've covered kind of the stuff to get you up and running with just that. So I'm going to go into some of the actual applications now, sort of clever ways that it gets used for. Let's consider sort of function you might see if you've got doing anything with a repository or a database. You go, all right then, so get accounts, and we're in ORM land, and if you come from C#, then what happens is if it does exist, then you'll get back if the accounts exist, like count 1000 exists, then you'll get back a record of why is that. Going up there? Oh, it's because I'm missing the other. I'm not even sure which extension is that's doing that. Alright, so standard ORM behavior in C# and Java says go to the database, get me back an account, and the ORM goes, yep, but what do you do if the account doesn't exist? Well, in that case, you get return null. It's pretty standard ORM behavior, and it sucks. Because now, you've got to remember to do the null check, because you might have an account, maybe, or maybe not. So yeah, I don't know. So you might get an account or not, and if you don't remember to actually do some sort of null check for it, then it's going to blow up, or more likely it might actually drift around to somewhere else in your program where it suddenly causes a null arguments exception somewhere far away, spooky action at a distance. And this happens so much that there are sort of clever patterns for dealing with this. You know, a clever OO dev might say null object pattern, where instead of returning null, I'll return an object which is of that type, and I've just set sensible behavior for all of its methods. I have sensible behavior for things it should do if something tries to use it. So like it's no longer null, I'll pass that around. Someone said an interesting quote to me the other day, and I wish I'd remembered where they said they come from. They said that patterns exist to fill holes in languages, or missing features in languages. Well, that's a really good one. And you can see here actually in F#, it's complaining about me trying to return null, because whilst null does exist in F#, it has to, unfortunately, for the interop with C#, null itself is considered kind of bad, and you can't just substitute in null for another type, which is why it's highlighted in red there. Can't do that in F# at all. So, what can we do about this? So part of the problem with this is if we look at the method signature, it says, any integer you give me, I will definitely give you back an account. Absolutely, 100% guarantee, that's what I do. And that's a bit of a lie if it can return null. So, what do we do to fix that? So what if we say, well, for any integer you give me, I might be able to give you an account. Maybe I can give you an account. Yeah, there might be an account, there might be some account, so yeah, let's go, okay, let's declare a new discriminated union here. And you might get some account, or you might get none. And let's then take that and rewrite this one. Say, okay. Alright, so I've rewritten this now, and now, if you try and get an account that exists, you get some account. If you don't, you get none. So what you get back is what we call an option here. You say, you might have got one, but at this point here, you can't just pass this around inside your program everywhere you'd expect to get an account, because it's not an account. It's an option. Someone needs to actually pattern match on it and unwrap it and work out whether or not it's got something in or not before you can use it, which means that you have to deal with the possibility of it not being available here and now. You can't accidentally pass none through your program, because the rest of your program just deals with account. It doesn't deal with option, maybe, sort of, could be an account. It's account. You have to pass it account, type safety. So in order to go further with this, you can't forget to do your null check. Once you've done this, you have to actually unwrap it. And that's kind of useful because, well, hopefully it's kind of obvious that that's kind of useful. It means that you can actually push all of those checks for nulls right up to the edge of your application where you've got data out. You can deal with those cases there. You have to. The compiler won't let you go any further without dealing with those cases. and then the rest of your program doesn't have to have null catches in it. You don't have to worry about someone accidentally sending through null. So, like I said, I made a slight promise there. Where did my null go? Nulls are replaced with discriminated unions. In fact, this is so useful that it's quite common. Well, it's so useful that it would be useful to actually generify it and just go say, okay, extend that. It doesn't have to just be accounts. It can be any. It's a generified type now. You can use that. It doesn't have to be for accounts. It's just of type A. It could be some A. You can see there that's an account 5 option. And in fact, it's so useful that that is actually part of the core library. It's just built into the language, and it's really common to see being used around. So like I said, so you unwrap it as close as possible to where you actually get the option out. And I made a note here, discriminated unions are low ceremony. I think I probably meant to put that note somewhere else, but yeah, it's a good point. They're low ceremony. It doesn't take much to create one, it doesn't take much to unwrap one. So it's easy to use them inside there. You can use them inside the method signatures to do unwrapping. You don't have to deal with it inside your function. You just deal with the unwrap values in there, but you can't accidentally pass in the wrong time. So coming up to, let's do one. Let's cover another one quickly, and then we'll have a small break. So, option works great for when there might be something or there might be nothing at all. But I talked about validation earlier as well. And in validation, we have something else that happens. Oh, in fact, let's pin in validation. Let's deal with something else. Okay, go back to validation. All right, divide. Common in all programming languages. And what usually happens in all programming languages, or most programming languages, is that you try and divide something by 0, then else, right, fairly common. You go, okay, divide x by y, and that's fantastic for every possible scenario apart from the one where y is 0. And this is in the core library for most programming languages. You do a divide, you hit 0, you get an exception. And this is also kind of sucky, because we've got a method function signature here. We've got a signature that says, if you give me any integer and any integer, I will give you back an integer. And this is also a lie. Because truthfully, what it's actually saying, well, it says that, but what really happens is you give it any integer, and it'll probably give you back an integer, or it might just blow up in your face. And obviously they're trying to solve this one in Java by having declared, was it declared exceptions? I think that's what they called them. Checked exceptions, where when you actually defined the class, you also, or method, you had to define any exceptions that it might throw, so that anyone consuming it would have to deal with those exceptions. They'd have to catch it. And everyone thought this was a great idea because it would solve that problem of things like divide by 0 errors, wobbling up through the code and blowing up in unexpected places. And we all know now that it was a terrible, terrible idea and should never be done ever again. So in C#, if you do something like this, it blows up in your face without warning, which is somehow less painful than actually having to plan ahead and deal with it. But once again, we can do better than this, because what we want to say is, okay, you've got two numbers, you want to divide one by the other. And how about instead of just saying, instead of giving you back that one, let's go, okay, so if y is anything other than 0, then okay. That was error. Divide by 0. So this is another discriminated union type that just comes in the language. It comes in F# 4.1 because everyone just started rolling their own one of this in every project they did. But this is now a discriminated union. It's a type. It's result, and it's generified again. You can attach a value, a value tagged as OK, and you can tag a value as an error. And what I'm saying is now, what you'll get back from this divide operation is a result. It might be OK, in which case you can see here OK it contains an integer, or it might be an error, in which case it has a string explaining what that error is. However, now, rather than it blowing up in your face, we're kind of, it's not as invasive as Java's declared exceptions, but once again, you're not getting back an integer. You know that you will have to deal with that case there. There are other ways of dealing with it. You could also, actually, instead of saying, you know what, you could make a discriminated union, single case, which is tagged integers which aren't 0. You can provide a constructor that checks that you're not trying to construct a 0. So you could actually make a type which is a non-zero integer. And now instead of passing in any old integer, which could be 0, you can declare a type non-zero integers, make it so you can, with a private constructor, so someone can't just make any old integer one. And now when you pass that around, you know that it's not going to be 0. You might see this also being commonly used because we dealt with IDs on accounts earlier, and ID is often just set as an integer, and that's a load of rubbish. All integers are not valid accounts IDs, all integers are not valid for looking up accounts in databases. It makes no sense to have an account with an ID less than 0 or even equal to 0 or equal to int max value. There are not going to be 2 billion accounts in your database. So,
Andrew, I don't want to derail you, but can you give us an example of how you would set up a private constructor for a discriminated union? Because that's...
Yes. So, here we go. Let's say, in fact, let's just go for that non-zero int equals, we'll go for the single case discriminated union of int. I'm going to get this right. But there, I can actually just declare that as private. That? And that is module private.
Oh, okay.
So, inside the module that this is in, I can easily have let's say create it, and if x is not equal to 0, then some non-zero int of x, else none. So I can provide a factory function to actually create that, because if this is inside the same module, the constructor is module private, so it can call it. Non-zero int itself can be passed around in other modules. It does have, it's a slightly bit finicky because that means you can't deconstruct it in a normal way, so you do need to then have a you need to provide another factory
Yeah.
to deconstruct it.
Yeah. And does that work for multiple case discriminated views as well, or do you have to put a private on each case, or just out of interest?
You
Or do you put it at the
can,
beginning, or? No.
I think you can make particular cases private.
Yeah.
So this one, yeah, would actually just be, so deconstructors in the signature.
Nice.
So yeah, it's slightly more fiddly because then you can't use the deconstructor in line. You actually have to then call the deconstructor. But it is very useful then. It's good when you do have things where there are criteria. You can't have an account that's outside of, well, it can't be smaller than 0, it can't be greater than 99999, whatever. It can't be 0. It's good for things like, well, you've got database tables, you use some strings, and we just go, all right, so we've got some text. Excellent. Unfortunately, of course, the database table is set up with n varchars. We've got set column widths, so not all strings are valid. We can settle on things like you've got, I usually cite Twitter at this point, and the tweet being 140 characters, but they changed that now. Okay, if this is meant to be a string that's going to hold a tweet, you can set up a discriminated union single case. You can knock it down to have a maximum of 140 characters, and you can't. And you can see actually with this one back here, we're also using, it's not just making the non-zero int, but we are once again wrapping it inside sum and none with wrapping inside option. And we're going, okay, you give me a vanilla integer and I will try and make it. If it works, you've got one back. If not, you've got to deal with that. Yeah. But you won't have an invalid one to just be passing around.
Yeah.
Yeah. Is that all making sense to you? Mm-hmm. It's 8 o'clock, let's take like a 5 to 10 minute break, and then I will hopefully then show something a little more in depth that's kind of practical application for this, but we'll do that after the break. Quite quickly. Alright, so yeah, I was going to show the second bit, sort of practical application, some of this DU stuff, and this is totally and utterly cribbed off of Scott Glashan. So yeah, if you want to see it explained far better, go to F# Fun and Profit and have a look at what he calls railways programming.
Yeah.
Yeah.
It's how it's the core pattern for SWAG as well.
Yes. So when you got that kind of happy path when you say have got some data off a user, they filled out a form on a website, and you go through and you'll do some stuff like, okay, let's go and make this big again. Boom. There you go. You've got your use case here. You get something in, like a string. Imagine it's more complicated than this. It's like an entire form full of information. And you've got some steps you do. You want to validate it. And then you're going to canonicalize it, so validating, you might just sort of check it doesn't have it's a username, it can't have spaces in, it can't be empty, you might want to canonicalize it, you might want to trim spaces off the beginning and end, you might want to lowercase it, and you might want to persist this. And this is kind of the happy path sort of thing you see, it's like a bunch of boxes, validate, canonicalize, persist, yay, happy path. And then what happens is you actually start writing that code and you go, okay, so validation, okay, let's split this up. We want to check that it's not empty, and we want to check it doesn't have any spaces in. Okay, if it does, if it is empty, then we raise an exception maybe? If it's null, we raise an exception. If it's got spaces, and it's like, okay, you did have this nice sort of flow, you had your use case, validate, canonicalize, persist, and now you've got to wrap it in a whole load of try catches, or you try and get a bit more clever and perhaps start looking at doing some of the, of using some of those discriminated unions we just looked at, like options or results. So what might that look like? Let's actually just go and change this to, okay, so If it is empty, then we might go none. Okay. Then oh, in fact, no, let's not have none. Let's actually turn it into results and then go error. Can't be empty. Go, it's null, then error can't be null. Can't be null. Otherwise, it's okay. Yeah. Okay. Yeah. Okay. So, well, now returns the results. Let's just plow ahead. If it contains a space, then go. Error. No spaces. Otherwise, okay. And oh dear. So I can't just plug the value from this because no spaces expects a string. And actually I've got a result, so I need to do something like maybe start going, okay, let's match that. Just do it with, well, if it's okay, then no spaces it. If it's an error of something, then I will just pass that error straight through. What's that? I'm happy with that.
You missed your pipes at the beginning of the match. Before okay.
You're absolutely right, yeah. And, oh yeah, this is complaining because then it should be else's.
They could also be matches as well.
They could be. We could match on an empty string, we could match on null. But the point I really want to get to is you can already see that the validate method is starting to get a little bit, and then we got the use case which is not just going to validate, but we're going to have to do something similar to canonicalize, and then something similar again that's going to become kind of, well, we'll end up with a sort of nested thing here where we'll match, was that okay, then do this. Well, if it was an error, then error. Otherwise, if it was okay, then, well, match on that, and it's end up, it's kind of callback hell almost. But that kind of, yeah. So, you know, okay, well, that was a bit disappointing. I was sort of hoping that we could do something a bit nicer, and of course we can. We don't want to, we don't need to do, well, let's just turn back the clock slightly. What I really want to do is still keep it looking, let's fix this. I'm cool with these like this. I do want it to return whether it is an okay or it is an error. But I don't want to change my validate, well, I don't want to change my use case too much. I want it to still read quite smoothly. But I have a problem here that these were strings that returned strings before, but now they return a result. So I need to do some kind of unwrapping because these functions still expect, so it's not empty here returns a result, but I can't just play it straight to those spaces because I expect a string. So I need to do a little bit of unwrapping here. So much as you would, if you have an object and it isn't quite the right shape in C# or Java, you can write a wrapper class around it to turn it, to adapt it to the shape it should be, renaming methods or whatever. We can do the same thing in functional programming, except instead of being a wrapping facade, wrapping object, we just wrap it up in another function, a function that transforms what we've got into what we want. Something a bit like, let's take this, bump it up. Sorry. Okay, bind. What the hell is this? So, the behavior that we've got is that we've got a result here, and we've got a function that takes a string. So we kind of want to go, okay, well, it's a result. If the result is already an error, then just return that error. If the result is an okay, then unwrap that value and apply it to no spaces here. So let's go. Boom. Hasn't changed validate too much. But now, what does bind do? Let's look closer here. So bind takes a function and an argument. You can see from the type signature here, it's a function of type whatever, but the argument, as inferred from what we're doing here, is of type of result. And what it will do with that is it will then you pass in a result of the appropriate type. So yeah, you know, we've got a type here, we've got a function. Let's look at it. We've got no spaces here. It takes a string. So up here, this type here, tick A would be a string. So we've got a function that takes a string and converts it into a result. And then we pass in a result which has an OK already of tick A, which was string, i.e. the one that's come out of it is not empty. And we'll then produce a new result, type B, which will be string, what comes out of no spaces. We're just kind of sitting it in front of no spaces here. It's passing in no spaces, and all it's doing is a bit of the pattern matching. We've got an argument here, it's a result. If it's already an error, then just return that error. I don't care, don't do anything further, we can't do anything further, there's already been a fail, just carry straight on. Otherwise, we're using the deconstructor here from OK to extract the string, the original string we had, and then we're applying it to the function that we passed in. In this case, it would be no spaces, which of course then produces another result. But I was able to then just plonk it in to the pipe, like so. And it would actually end up being the same. I haven't bothered with the canonicalize and persist methods, but the exact same thing could be done to here. And with the addition of that simple bind method there, and function there, we are able to carry on using our use cases and the functions we've already written, which just take strings. We haven't had to deal with the fact that it was a result. We've just written an adapter that we can slot in to these pipes. And we can still keep the code nice and clean. We're not dealing with results inside there, we're still dealing with strings. We've unwrapped things, we've adapted them, we keep the use cases nice and slim, we can still plug them together, they just have an extra little bit here. And once again, this is, I think, such a common operation that, please let me be right, yes I am, it's part of the core library. So bind exists for a result there, and it allows you to unwrap, apply a function, carry on. And it also exists on the option discriminated union as well, in which case it will unwrap maybes and apply them to a function, or if it's none, it'll just return none, sort of short circuits. Now Scott Galashan kind of called this railway programming, because he kind of envisaged it as you've got your rail line, and there's the sort of success rail, but if at any point it fails, it gets onto a separate track, which is the fail track. And he viewed it as kind of like, okay, you've got a function and it's got one thing going in, it's got one track going in, which is like your string, and it's got two tracks coming out. So like it succeeded or it failed. And then you have a whole bunch of these, and they've all got one thing going in, but the succeed or fail coming out. It's like, okay, so what do you do if you've got a train set like that? Oh, you've kind of got adapter bits. You just go, okay, we'll stick another bit of track around it, so that if there's already an error, that goes in and just goes straight onto the error track. So if it goes at any point onto the error track, it's on the error track forever. It's just straight through. It doesn't bother going through any of the functions. And he has a whole series of other ones which are interesting, different shaped tracks, ones which might go off to several functions in parallel and then come back, or go off to dead ends, like persisting to a database. The result goes to the database. There is no continue going on after that. But I wanted to talk about this because this is kind of like where it starts kind of getting really powerful. It starts to speak the code nice and expressive. But also this is where it starts leading into something else I want to talk about in a future session, not now because we've covered quite a lot of ground and this is enough for its own thing, which is computational expressions. Because bind is one of the cornerstones of computational expressions. Have people heard of computational expressions before? I know you have. Okay, so let's take a step back. Have people heard of monads?
Heard of them.
Yeah. Okay. So what you actually witness, or what you've seen here today with, let's just go for, let's go back here and have a look at the option I did. We go back and have a look at option here. Okay. So this is one of the most basic monads out there. I'm not going to go too crazy talking about monads because I don't want everyone to run away. But a monad is, I'm going to do a terrible job of explaining this. In its simplest form, it's a wrapped value. You start off with a simple value, maybe a string, and then we've turned it into some sort of superclass, wrapped class. It's a string at its heart, but now it's wrapped up in another class, another object here, which says, well, it might be, it's an option. It might be a string, or it might be a null. But you can still pass it around quite happily, and you don't need to worry about whether or not it's one of those until you want to unwrap it. And it allows you to do things like, with bind there, we don't need to deal with the consequences of, say, the result failing every step of the way. We don't need to do a, well, check if it's null. All right, deal with the consequence of that. And then, if it was okay, carry on and do the next bit of validation. Did that succeed or fail? Let's deal with the consequence of that. By being able to wrap that up inside of another type that actually represents whether it was a success or failure, but not actually resolving that now, we can kind of pretend, well, we can express, we can write it out in a way that just treats it as, yeah, you know, just keep going. And bind will kind of short-circuit things when something actually gets evaluated. So we can build up these chains. You sort of see it in promises as well if you come from Node, or domain Node. If you've got a promise, you've got something where you kind of promise that there will be a result in the future. Now, obviously, you carry on stringing things together. You don't have to sit there, then the program doesn't wait for that to evaluate now. It can carry on doing its own thing, and when that promise actually fulfills itself and is realized, then it will go and do the next thing. But you don't have to sit there and go, right, wait until it's done. Is it done yet? Is it done yet? Is it done yet? Yes, go, next thing. Is it done yet? Is it done yet? You don't do that. You just wrap it up. You promise chain. And it's the same thing. You're wrapping up what is the simple type, which is whatever the promise is going to return, into a promise. And now the language then deals with the kind of fiddly bits, the imperative bits, the procedural bits. If you've done asynchronous in C#, it's the same thing. The async await library allows you to pretend, we all know that it's an asynchronous result, you're getting back. In reality, there is an asynchronous job, and you might have to do all sorts of things, once again, waiting for its value. But you can hide that fact and go, okay, it's an async, and it will return an integer. And then you just carry on coding, as if you have that integer. And of course you don't, you've got an async, but it's hidden from you again. And this is kind of what monads are, or a use of monads. It's a wrapped type, so that might be a simple thing like whether or not it's actually anything at all, in the case of option, whether or not it was success or failure, or it's something which is going to exist in the future but doesn't quite now. Or a computation that's still to happen. If you use link, this is the other classic example in C#, you're doing things with IEnumerable. What does an IEnumerable say? It just says there's something, and when you ask for the next one, you'll get it. You can enumerate over it. What form that takes, I mean, we usually use lists for it, or some other form of collection where obviously it's backed by an array. But there's nothing really to stop it being an IEnumerable actually listing on to some sort of service, and you just go in and get the next value that's come from that. All you're saying is, it's something I can enumerate over. And inside of my select statements, I just treat it as if it was an integer, because at some point there will be an integer. Numerable in that case allows it to do all sorts of things like, well, deferring even getting that next one, or working out if it even exists, because we're passing it around wrapped. We pass it around as an enumerable, we pass it around as a promise, we pass it around as an async, but inside the code, we pretend it's the wrapped value. How is that for an explanation of monads?
Is it monads or monads? I'm not quite sure.
Sure.
See, because
you want to really throw me say symbols and monoids, because
yeah, that's
we can't do that one off the top of my head.
That's like the endofunctions.
Yes.
Oh, that one, yeah. Every now and again I go away, look it up and go, okay, that, I'll remember that. No, I never do. Any questions about that? Because, okay, have I covered what I'd say I was going to cover? So, discriminated unions. Does everyone get now how, using something like the option, discriminated union, you have to deal with nulls? In fact, it's how F# gets around nulls, and I really wish they'd put something into C#. Can but hope, since they're slowly moving all the features from F# into C#.
They're doing a nullable reference type today.
Yes. It's not quite the same thing, but it's a start. So we don't need to worry about nulls in F# so much, unless you interact them with C#, in which case, tough. Guards. So we put guards in because we have to check that certain values, which we claimed we accept in the functional method signature, are valid when really they aren't. If we wrap up things in single case discriminated unions, we went a little further and showed private constructors and factory methods for only building ones which were valid. Gets rid of a lot of the guard clauses. Validation. Did a very quick whistle-stop tour on Rails-oriented programming, because you do an entire Railways programming, because you can do an entire session on that. But hopefully it was enough to sort of show you that you can kind of wrap things up with a little bit of an adapter function, keep your actual use cases still quite sort of short, sweet, easy to read. I think that's kind of the important takeaway, is that rather than nesting lots of try this, then do this, if it failed, else do that, we can carry on just piping things along as if we were still just dealing with a string, just by putting a little bit of an adapter in. So we can keep, because your validation and your use cases should be easy to read. If there's lots of nested conditionals, well, if the previous one worked, do something else to this, they're not readable. And, oh yeah, I should have put polymorphism at the very front of this, because it's kind of the first thing we covered. how we can actually now do that kind of understanding that there are collections of things and we can pass around the idea that, well, it's contact details. We can just pass contact details around and we don't need to worry about whether that's an email, mobile, landline, or something we haven't thought of yet until we actually need to do it. So. And this leads to some interesting stuff, specifically around, say, null, guards, and validation, very much around null and guards, in that this is part of why people find it really hard to TDD F# and other functional programming languages. Part of the problem is that a lot of your unit tests are to catch things like this, nulls, guards, all that, and check for them, and check that they're being dealt with. A lot of that doesn't actually apply in F# because the static type system means that at compile time you know that lots of those things can't actually happen, and so you don't need to test for it. So I think I imagine people are familiar with or have heard of the book Growing Object-Oriented Software Guided by Tests. I can't remember who by. But it's one of the famous ones, which is, it's a good read, apart from the fact that the example they used all the way through is really boring. But someone then said, I think it's probably Scott Willashen again, because it's always Scott Willashen, and said that what happens with F# is you grow the software first by defining types. You can go an awful long way with the static typing system in F# to actually make compile safe code without actually having to do even tests to prove that. He does quite a nice example on his blog where he shows codifying most of the rules for noughts and crosses into a program so that before there's even any logic in it, it already can't break. And this is part of what makes, this is what was interesting to me when I first got to this point in F#, was realizing, oh, this is what a static type system is. Because I've grown up with Java and C# and C++ and gone, okay, those are static type systems. It's all about classes and interfaces and abstract classes. That's what a static type system is. And then you sort of get into cases where you start jumping through all sorts of hoops to make it work. And then you come across something like Haskell or F#, or one of the strongly typed functional programming languages, or statically typed functional programming languages, I should say, and realize actually the type systems with discriminated unions and the like can be really quite expressive, and you can bake safety into your code just with the types, without having to put in guard clauses, catches, and everything. So, yeah. Any questions?
What's that guy called that you keep quoting?
Scott Willashen. He sounds like he should be from America or something. That's a very good point. In fact, I have the internet. Why am I even... I can go one further. Scott Willashen. Yeah, this is the guy. Has a Twitter account. And more importantly, he has a really good website called F# for Fun and Profit. Millions upon millions of articles, and I assumed from reading this that he was an employee of Microsoft and presumably worked in America. It sounds like he's got an American name. Actually, he lives on the Isle of Man. And I don't know if he works for Microsoft. No, I don't think he does. He's not affiliated with Microsoft, and he just does this for fun. And yeah, he has written a lot. So this is an excellent place to get into the language.
Yeah, I've got the do our oriented program page open at the moment. I was reading them the other day.
Yes, can I find yeah, there we go. Railway-oriented programming. That's what I was referring to there. That there's enough really to do an entire session on it by itself. Boom. there we go. Examples of writing adapters and snapping these tracks together, success and fail journeys. What else does this one have? Okay, a whole lot of stuff.
It's massive then.
Yeah, it is actually. I'm looking at the right side of the page and scroll by. Yeah, it's a massive page. It's a massive article, and it covers. Yeah. Yes, I forgot to say. So yes, binding is part of the thing that allows computational expressions to happen. So because it's so common, along with a couple of other bits, there is syntactic sugar in the language to write computational expressions, which look a bit like you're just working with the unwrapped values, but it deals with that kind of, you can see here I'm doing things like, I do have to put the bind in. In computational expressions, it's a block where you can actually just pretend you don't need to put the binds in. It just does the binds for you, or it makes it look like it's doing it for you. It just adds a level of syntactic sugar on it.
Is there a builder for the result type? I was going to ask you.
For the result type, yeah. So we are there is. We've been using it here. There's constructive.
No, I mean, like, is there a computational expression built in for the result type?
I don't think there is.
No.
Not in my own experiments, but it is one that I wrote one for when I was trying it out. So if I do one on computational expressions, it will probably be the first one I do because it makes it nice and easy to sort of compare what you see here with what it then ends up looking like.
So something like this, it might even just look easiest to do as an infix operator.
Yeah.
Okay, the same thing. Flow quite nicely, isn't it?
Yeah, that's good.
I've read something, there's a sort of subtle issue with railway-oriented programming, somebody pointed out, which is that, because there's a temptation then to go, oh yeah, get rid of my exceptions everywhere, and I'll turn it all into results. Except that you don't actually know how far down you might get an exception. So if you're dealing with stuff that you don't explicitly control, you've written all this lovely, it looks like beautifully safe code, but you've forgotten that, oh yeah, I might get a memory out of, memory or something like that. And so it blows the whole thing up, in which case
you push all that out to the edges, so once you get to your stuff, you never dip into any other code. You've got the values that you want before you go into the memory.
I think it's the unfortunate bit that yes, the language itself still quite happily throws exceptions when you try and do things like divide by 0. And if you've forgotten that you can do your own validation or whatever, you can still be tripped up because you've not thought of something that can throw an exception. It's a shame you can't 100% bulletproof it. If that's your thing, you can probably go to Rust, because that's their promise, isn't it? That it can't throw a runtime exception. That's what they try anyway.
I think you can if you hurt it enough, but yeah, pretty much.
Right. But there's no other questions.
There are, one of the things, the discriminated unions, that does seem to be becoming quite popular now. So yeah, Rust, but also it's the big thing in what's the Apple one?
Swift.
Yeah, big thing in Swift.
Yes, it's coming in lots of things. In fact, we were just mentioning Rust there. Rust's enums, which are used extensively throughout it, are discriminating unions. You scroll enums there. You're right. Scala has case statements. Swift uses discriminated unions. We'll probably be getting them in C# soon. Java 9, I don't know if that has anything equivalent in it, but it's probably coming. So yeah, everything. Cool. All right. Mike, do you want to take everyone to the pub? I unfortunately can't stay out tonight, so I have to go and prep for another session tomorrow night, which I haven't finished either.
This is your typical development environment, VS Code and whatever extensions you've got.
So the extensions I have here, it is for F#. I'm using VS Code and Ionide, which was originally a set of plugins for Atom. In this case, Ionide F#, because it adds in the IntelliSense and the completions and the like. And it is my third one. I pretty much stopped using Visual Studio for F#. I just find that the F# code itself is pretty straightforward, and it's I don't need all the tooling that you get with Visual Studio so much. It might just be that I'm a hobbyist and have not done anything big with F# yet.
Yeah.
But I generally find, I found this with all functional programming languages, is that actually when I write functional programming language code, it ends up being a lot smaller and a lot easier to reason about, and therefore I need a lot less tooling around it. In which case, being able to fire up VS Code in half a second as opposed to spending 2 minutes starting at Visual Studio is highly preferable.
And then more 10 minutes waiting for ReSharp to start.
Yes.
First word.
Cool.